Yes, class. Am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
All right. Who is this? Hafsa, Fia have attended the last class. What is your name? The third person, Deborah.
Yes, ma'am.
All right. Am I pronouncing it correctly?
Yes, ma'am.
All right. So yes, in the last class it was just an introductory class. Only we had looked up the syllabus and the basics of this lesson. No, we had seen what is an Fia, you were asking, I think, something. Tomorrow, do we have an extra class? Fia, you have to join that batch, which I have told you. There we'll complete the lesson.
Okay, ma'am. But is there extra class?
No, apart from it, it's not needed. See, that will be over. That lesson will be over tomorrow. So your half lesson will be completed. And then the magnetics 5th lesson, 6th lesson, there it will start. So if it is needed, that let's see towards the end of August. Let's see how much we are able to complete. All right.
Ma'am, but if it is end of August, then because September 2nd week exam, right? Before that, other exams will start. So it
Okay,
will
let's see
not
till the
be.
mid of August. Let's see how
Yeah.
much we are able to
Okay.
cover in both the batches.
Okay, ma'am.
So electric charge, we had seen it's the intrinsic property of matter which gives rise to electric forces. Among this, I had told you, you have to remember this value, that how much charge is held by an electron. This we call as the electronic charge. 1.6 into 10 to the power minus 19 coulomb. This value you all have to remember, and this will be used throughout. Now, see class, one thing that I wanted to discuss, which is very important for your basics. This won't be asked anywhere, and this you people know, but in detail you haven't studied it. That's why I just wanted that at least you people have an idea of this. See, when we talk about a nucleus has around itself orbits within this nucleus, you have protons, you have neutrons, and around this nucleus, you see electrons which are evolving in different orbits with different number of shells. This you study in detail in your structure of atom in chemistry, right? So what are the forces that are acting in here? See, within the nucleus, now why is the neutron and why is the proton held very well inside? Because there are presence of nuclear forces. First, the type of forces that exist, these are nuclear forces. So nuclear forces, these are held within the nucleus. So within this nucleus, these protons are held, these neutrons are held, and they are held very tightly because of presence of these nuclear forces. And these nuclear forces are very strong. In your first lesson, that is physical world, if you go through the lessons, you see a page is there where about the forces is mentioned in your class 11th. Physical world is the first unit. So there you see the first unit is mentioned, in which the first lesson has some things about the forces. But in any ways, we study about these forces in detail. So what are the first type of forces that exist within the nucleus? These are your nuclear forces. These are very strong forces which hold the neutrons and protons tightly in it. Now coming to these electrons are held through electrostatic force. These electrons are held through electrostatic forces. Now you have two types of forces in your system. One is your nuclear forces, with which the neutrons and protons are held tightly. And the other type of forces are your electrons. These electrons are electrostatic forces of attraction, right? So now what happens? if all these entities are present within this, which quantity moves, or why are we able to call a quantity as positively charged or negatively charged? That's what I want to discuss with you, because this part you already know. See class, this nuclear force, no, nuclear forces are very strong. They are very strong. If you see the relation, the nuclear forces are 100 times stronger than the electric forces. They are 100 times stronger. It means they won't allow the neutrons and protons to escape. And in comparison, you see these electrostatic forces, these are comparatively weak. You can see they're 1 by 100th times weaker than the nuclear forces. So if an external force occurs amongst these two forces, only electrostatic forces will be allowed to remove, right? To be removed. Why? Because nuclear forces are strong. These strong nuclear forces, they hold proton and neutron so tightly among themselves, they do not allow them to move. So what you have to remember, it's the electrons which ultimately electron has to ultimately move out of the atom. And when the electron moves out of the atom, we call the particle as negatively charged particle. And when electron enters, we call the material as positively charged material. It's the transfer of electrons that occurs, not protons, not neutrons, that make your bodies positively charged. Even if a body is positively charged, that is because of deficiency of electron. If body is positively charged, this would be positive. If electron is getting removed, then it would become positive, and if electron is entering, the body would become negatively charged. Deficiency of electrons create positively charged, and excess of electrons create negative charge. So electrons are comparatively weakly bounded than protons. Because of this relation, you have electrons that are transferred, not the protons. All right, this you people had written in the last class, right? Till here you have written, no? Before we start with charging, okay, let's start with charging, because this is related to this. Charging means simply transfer of electrons. Now, is this clear that it's the transfer of electrons that occur? Nowhere you will mention that it's proton that is making a body positively charged. No, deficiency of electron is making a body as positively charged. Excess of electron is making a body as negatively charged. All right. So nowhere you will ever say that proton is being moved or neutron is being moved. It's always electrons that are traveling. Secondly, this process of traveling of electrons, or transfer or redistribution of electrons, best word is transfer of electrons. This is what we call as charging. So negatively charged body, these are gained by electrons coming, and positively charged bodies are made by electrons that are being lost. But before that, have an example. Have a look at this example. See, there are 4 electrons present. There are 4 protons present. So what is the total charge on this particular body? Plus 4 electronic charge, 4 protonic charge, because charge of proton is also E, right? What did we study in the last class? Charge on proton and charge on electron, both is 1.6 into 10 to the power minus 19. It's just that we put a minus E for electron and plus E for proton. So if 4 electrons are there, we'll put minus 4E. If 4 protons are there, that becomes plus 4E. So plus 4E for these 4 protons, minus 4E for these 4 electrons. What is the net charge? Net charge is 0. They cancel each other, the net charge in the 0. So such a body, this is known as a neutral body. These are your fundamentals of electrostatics. Afterwards, we'll be just using the term neutral, negatively charged, positively charged randomly. Since it's your proper first lecture of your electrostatics, that's why we are discussing in detail about these concepts. Now we'll be rushing with the terms. So that's why pay attention right now. So this is a neutral object, because positive charge and negative charges are balancing. Let's say the mass of this body is MA. So this is having the charge of the mass of 4 electrons, 4 masses of electrons. First, tell me, till here, do you all agree till this concept?
Yes, ma'am.
All right. Now see, suppose I have moved one of this electron and 1 electron has been added up here. Now let's see the differences that come in the body. Now the charge of this body A. How many protons? Plus 4e. But how many electrons? Minus 5e. What is the net charge? Minus e. Minus means the body is negatively charged body, right? And what about the masses? Mass of A now. This is 5 times the mass of electrons. What can you conclude? As the electron is gained, the body becomes negatively charged and the mass increases, right? The mass increases. Suppose, let's say I've removed one electron from here. Now, what is the charge? Plus 4e because of...
Ma'am, for mass will take only electron.
We are considering the masses of electron because masses of protons are same in every case. So
Okay,
answer
ma'am.
won't change because of that. You will have mass of proton also. Whenever we talk about it, mass of protons are also considered in the structure of atom. Right now, since in this example, all are 4, that's why I'm not considering it. Then there are 3 electrons. So minus 3. What is left? Plus E. Plus. It means the body became positively charged as the electron was removed. And what about the mass? It became 3 times mass of electron. It decreased from 4 me, it became to 3 me. What are the conclusions you can make? See, the conclusions that you can make is, as soon as an electron is added in your atom becomes negatively charged, first point. And when the when the atom becomes negatively charged, the mass of the atom also increases because of the associated mass of this electron. Electrons are not massless entities, right? Electrons have their masses. Mass of electron, you have proper mass of electron, 9.1 into 10 to the power minus 31 kg. This much mass is being held by a single electron. One electron is holding this much amount of mass. So if 5 electrons are there, or even if a single electron gets added, mass will increase in your system. But as soon as this mass is removed, one electron is removed, this amount of mass is removed as the because of removal of one electron. So object becomes positively charged, your atom becomes positively charged, and the mass also decreases. So do associate mass, because these electrons, these are having this much amount of mass, 9.1 into 10 to the power minus 31 kgs. Note it down from here. And do mention this fact that electrons transfer. It's the transfer of electrons that occurs, not the transfer of protons. And have it in your mind also, electrons are only mobile elements. And most of the cases you will notice that positively charged particles are immobile. They do not move. Done, class?
No, ma'am.
Okay, okay, take your time.
I'm done.
Now, class, methods of charging. See, there are three methods of charging which you have to remember. Charging by friction, charging by conduction, charging by induction. Now, see, when I use the term charging by friction, this means transfer of electron with the help of friction, right? Transfer of electron by conduction, by induction. So these are basically the transfer of charges in itself already. So charging by friction, this is the easiest one. This is similar to this. See, what is friction force? In class 11th, you people have studied friction force. Friction force is basically a force that opposes the motion. It provides resistance. So how does friction force can be generated? Just by rubbing two objects, right? Even if you take your both the palms and rub them against each other, you will see your palm will become hot. It will become hotter. Why? Because of presence of, yes, force between two surfaces. Exactly, Pia. Because of the irregularities that are present. And when these irregularities are rubbed against each other, it produces heat. In the form of dissipative force, this arises. So these are from your basics of class 11. So because when two bodies are rubbed, the electron gets transferred. Why? Because whatever is the work done when two objects are rubbed, it's like these are irregularities present of one surface. These get interlocked with the irregularities present on the other surface. And when these are rubbed against each other, heat is generated. Why heat is generated? Because friction is a dissipative force. So this heat energy facilitates transfer of electrons from one body to another, like this. This is one method by which two objects can exchange electrons. And this is a very good method that you have to remember, because you have a question in your in-text also in your NCERT, for which one concept you have to remember, that is strongly bound or weakly bounded. Now see, suppose this is a body A. A has 4 electrons, A has 4 protons. What is the charge on A? Plus 4E minus 4E, that is 0. What about this B? What is the charge present on this B? Can anyone tell me? By looking at the figure, what is the net charge on this body B? Yes, Hafza.
0.
0. Perfect. Because, yes, Fia, 0. Because see, charge on body B plus 5E because of these, and minus 5E, this is 0. Now what we do? Earlier in the previous question, I had taken proton same, which Fia, you were mentioning also. I had taken proton same. That time also, that time I was obtaining different values because protonic number was same. Even if here I make the protonic number same, I'll get negatively charged and I'll have my answer, which is negatively charged, which is positively charged. Now what we do? So here you have a concept, that is the concept of strongly bound or weakly bound. This you have to remember, strongly bound or weakly bound. Strongly bounded or weakly bounded, this you have to remember in the sense that this will be given in the question. What you have to remember is how you are going to apply this. Now see, till here you people have understood. This is given in the question that in B, electrons are strongly bounded in B. This is mentioned in the question. It means, see,
Ma'am,
what
because
we do-
mass is more.
no relation with mass, because whenever we talk about mass, we talk about the mass of a single electron, which remains constant. But overall mass is more. That doesn't define that it is strongly bounded, because when we talk about the boundations, it is always between one electron and one proton. So even if there are hundreds of electrons, we just compare it through these. Question is that, or the problem that arises is here is, when we compared these two, we had this relation. And this relation helped us deciding whether electron would move out or proton would move. But when we have two electrons, this and this to decide, now we are having issues, no? Because both are weaker forces, both should move, and they are both are electrically neutral. Now we go with this definition of bounded and unbounded. If it says in B, electrons are strongly bounded as compared to A, it means the removal of electrons, the removal of electrons in B is difficult in comparison to removal of electrons in A. This
As it has
force,
most number of electron, ma'am.
that doesn't affect it, Fia. Always remember, even if there were 4 electrons here, that doesn't affect. It means, this is what this means is, see, this force of attraction, let's talk about this force of attraction between this electron and this proton. And let's talk about the force of attraction of this electron and this proton. This electrostatic force, this is stronger in comparison to this. Let's say this force is having certain value. Let's say this is having 50 Newton. We know both are weaker forces in nature if you compare it with the nuclear forces. But when we are comparing these two, let's say this is 50 Newton. So this must be something around as 45 Newton, like this. So which becomes weaker? Ultimately, this becomes weaker. Now, how will you decide whether this force is more or that force is more? That is with the help of this concept, which is already given, strongly bounded. It means this force is more in comparison to this force. So you can removal of these electrons become easier than removal of these electrons. These are rigid, these are fixed in comparison to this. So what happens? One electron gets removed from A to B. This is how in rubbing, that is charging by friction, you people have to identify which charge will move. Till now we were studying charges move, electrons move, protons do not move, neutrons stay, nuclear forces were stronger, electrostatic forces were weaker. This we had studied. But when actually two bodies are present, electrons will move from where to where? This question is determined by this strongly bounded or weakly bounded. And that helps you in determining whether the body is positively charged or negatively charged. See, if this had strongly bounded electrons, it means electrons from A has moved. So this becomes positive, this becomes negative. You will have questions where you have to identify which body is positive, which body is negative. I'll make you do these questions. These are questions, but before the questions, no, this is present in your NCERT, and these two data, these are important. Rest of the data which are present, that you need not remember. because there are plenty of data which are categorized by convention as positive and by convention as negative. But through certain experiments, it was concluded that glass rod becomes positively charged and silk becomes negative. It means electrons move from glass rod to silk cloth. Whenever, no, if you take a piece of glass rod and you rub it with a silk cloth, then electrons move from the glass rod into the silk cloth. Same way happens if you take a wool and a plastic. If these are two rubbed together, transfer of electrons occurs in this way. Just remember these two. Only these two you have to remember. No other data you have to remember. That will be given in the question if something new is given. Object A, B, C, D, it will be mentioned. Because these are specially mentioned in your books. So from there it has been extracted out. All right. Do one thing. From here, charging methods of charging, write it. Then I'll discuss how to solve questions from charging by friction.
Done, ma'am. Done, ma'am. Done, ma'am.
Done, ma'am.
Yes, Fia, I'll see your messages. I'll see your message. I'll reply. But first, let us just discuss the portions of the class. See, note down this question first, then I'll discuss with you.
Ma'am, we will discuss at the end of the class, ma'am. Let the class finish.
Yes, Fia. Just please, first, let us have the class first.
Yes, ma'am, done.
See, the question says that if an object is made of substance A, this is rubbed with an object of substance B, then A becomes positively charged, B becomes negatively charged. Then it further says, if however an object made of substance A is rubbed against an object made of substance C. Let's see the first line. Substance B, A becomes negatively charged and B is negatively charged. A is positively charged. So you have A. See, you have A, which is positively charged. And you have B, which is negatively charged, right? This is given. So it means which is strongly bounded, which is weakly bounded. Electrons have moved from A, right, to B. That's why this is negatively charged once they are rubbed. So at least you can figure out from this that A has strongly bounded electrons. B has strongly bounded electrons. That's why electrons have moved. Now, second part of the question says, if an object made of substance A is being rubbed with substance C, then now A is becoming negatively charged. Look here. Now what is the case? This is A. Now this becomes negatively charged. And this object C, this is positively charged. So here it was easier to remove. Here it was easier to remove the electron. And if C is positively charged, it means electrons have moved from C to EA, right? So here it is easier to move electrons, right? This is easier. So what you can conclude, see, from A to B electrons have moved, and from C to A electrons have moved. We have to tell the polarity. What will happen if an object made of substance B is rubbed against C?
Ma'am, from C it will move to B, ma'am, as B is strongly bounded.
Very good. It will move from C to B. So what will be the charge on B?
Negatively charged.
Negatively charged. Very good. This will be negatively charged because electrons are strongly bounded here. And here the electrons are weakly bounded. So from here, can you figure out the polarity? If they are strongly bounded in here, B becomes negative and C becomes positive. This is the only way you have to answer all these questions. Quickly note down the solution, then we'll do charging by conduction. C class, the first method was charging by friction. So by just rubbing the objects, the heat that was produced, that helped in the transfer of electron, means charging of electrons. Now, the second method that we have is charging by conduction. So it is also similar to charging by friction, but the difference that arises here is, see, in charging by friction, both the objects were made. See, when the two objects, they were rubbed against each other for charging by friction, for the electrons transfer. In charging by conduction, you just keep the bodies in contact with each other. You do not rub the bodies. This is charging by conduction. So when an uncharged body is placed in contact with a charged body, it gets charged due to transfer of electrons. Now, what type of questions come in your exam? You will get both the bodies will be identical. And in the identical bodies case, the charges will be divided equally. Like if these are the two bodies, how will you identify whether the bodies are identical? If radius information of the radii are given to you, both the radii are same for the spheres, or if the sides of cubes are same, this is how you can identify, right? Otherwise, it will be mentioned in the question that two identical bodies are placed in contact with each other like this. Suppose in the first body, it is having 4e, 4 electronic charge as the charge on itself. And second body is completely uncharged, neutral. This is uncharged. So when we say the bodies are identical, and when you place them in contact, this is charging by conduction. Now electrons transfer will occur. So it will occur in such a manner that both of the bodies will be receiving same amount of charge. Charges will get divided equally. So what is the total amount of charge right now? 4e plus 0, right? That is 4e. So divided between the two bodies, divided by 2, that becomes 2e. Similarly, here also 4e plus 0, this divided by 2, this becomes 2e. So each body, this will receive 2e amount of charge, this will also receive 2e amount of charge. Initially, this was having 4e. This was 0. No charge was present on the body 2. After keeping them in contact with each other, because of charging by conduction, both the bodies received equal amount of charges. You can see, because now what is the total number of charge right now? 4e plus 0, this is the total amount of charge, and now divided between two objects. So that means each will receive 2e itself. Look, one more example is there. Yes, Fia. I landed 15 minutes before. First body is there. First body is having the charge plus 4e. Second body is having charge minus 8e. And let me mention the fact that both the bodies are identical. Now I have to find out the charge if they are placed in contact with each other. It means charging by conduction is following. So what is the total amount of charge right now? 4e minus 8e. That is 4e. So it means total amount of charge right now is 4e. So divide 4e between two objects, that is 4e by 2. So it means each will receive 2e. This also becomes 4e minus 8e divided by 2, that becomes 2e. So each will receive 2e. One question based on this also, let's see. Do one thing, note down it from here. Charging by conduction.
Ma'am, why did we add the charges here and subtract in the other case?
Because in the next example, it was minus 80. So even when you add plus minus 80, that becomes minus 80.
Okay.
Yes, answers of this question. Charges on A, B, and C. See, question says that two identical spheres A and B have charges plus 4e and minus 2e. So you have A, you have B. Now they have charges plus 4e and minus 2e. Plus 4e and minus 2e. A third identical and uncharged sphere C is first placed in contact with A. It means let's talk about this only first. This is C, this is uncharged. This is what is the question saying, no? A third identical. So now you have a hint about identity. Both are identical and uncharged. This is uncharged and we know the charge on A is plus 4e. They are made in contact. So if they are made in contact, how much charge now each will be having? 4e plus 0 by 2, 2e. This also 4e plus 0 by 2, that is 2e. Now it says, then with B. Now C is made in contact with B. Now you have you have C, which is being made in contact with B. C has now what, which is the amount of charge C has? 2e. What amount of charge B has? Minus 2e. So 2e plus minus 2e by 2, that becomes 0. 2e minus 2e by 2, that becomes 0. So at the end, what is the conclusion? A has 2e, B has 0 charge, C also has 0 amount of charge. This is the conclusion and this is how you have to find the charges. So from this section, only these types of questions come. Note down the solution. See, the last method is charging by induction. Then your charging methods will be over. Charging by induction means, see, if you are having an object which is neutral, see, amount of positive charges is equal to amount of negative charges. So we say the body is neutral. Right, you have positive, for every positive atom, you have one negatively charged atom. So you can say the body is neutral. Now see, positive charges are static. This I have mentioned already. Positive charges, they are static. They do not move. While the negative charges, they are mobile and they do move. So in charging by induction, a best example we'll take by bringing up a glass rod over here. Let's say I have brought a glass rod. Now what do I do? This glass rod, I make it positively charged. This glass rod, I'm making it as positively charged. So what will happen if this is positively charged? It will attract which type of charges?
Negative charges.
Negative charges. Yes, Afsar. So what happens? All the negative charges, these will come towards the end where the glass rod is present. Yes, like this. All the negative charges will come towards this end while leaving the positive charges behind. So till the time I'm holding this glass rod, what is happening? Both the charges are separated. As soon as I remove the glass rod, both will nullify each other. Again, the positive charge, for every positive charge, there will be presence of a negative charge. So that's why we say this method is temporary electrification. Why temporary? Because the charges are separated till the time the inducing charge has been kept. Till the time I'm holding the glass rod, only by that time the charges are separated. You can make the glass rod positively charged. There are different methods. See, if you rub it by silk cloth, glass rod will automatically become positive. Right, that's what we have studied. So various methods are there to make it. You can use friction and all to make it. You can just simply rub it with the help of silk cloth. Glass rod will automatically become positive. It will lose the electrons which will go into the silk cloth. So I was saying this is temporary electrification because till the time you are holding this glass rod, only for that duration of time the charges have been separated. As soon as you remove it, the charges will again nullify each other and they will become back to neutral, right? Now the charges that have been separated, that we call as induced charges. And the object that is separating these charges, we call them as inducing charge. So this entire process of temporary electrification by which the charges can be separated, this is known as charging by induction. So when a charged body is placed near a neutral conductor, it induces charges due to redistribution of electrons. Now, once this rod will be removed, again, this body will become back to like this. Noted down the last method of charging.
Done, ma'am.
Fia, you can leave. You had to leave early, no? So this I will stop here today.
Yes, ma'am.
Tomorrow we'll continue the rest of the portions. You people can leave. See, Fia. Okay, just wait. Let me talk. Yes, you people can leave. Fia, you just stay. Tomorrow we'll continue. Okay. Devora and Hafsa. Fia, see, in this batch, 4 chapters will be completed by that time, by your exam. And in the second batch, in which you are attending classes, there also 4 chapters will be completed. So all your 8 chapters will be completed on time. Just in case, even if we are seeing the 4 chapters, we are not able to complete it in this batch. Because for the next batch, the chapters are very small. AC is very small, EMI is very small, EM waves is a very short lesson. Chapter 5th is also very small. It just takes one class for each. So that will be completed in that batch. Regarding these 4 lessons, the first 4 lessons, let us see how much we are able to do, because we have the target of completing the 4 lessons before your exam. All right. So if we are left with any portion, we'll have daily classes then. Okay, Fia?
Yes, ma'am, but it would be comfortable if it's like before the mid of August.
Yes.
It would be comfortable if it's before the mid of August, ma'am, if any extra class has to be held.
Before mid of August, at least let us complete with the syllabus, no? Because see, you have first lesson, you have second lesson. If I rush up in these lessons, already you are having those 4 lessons in hand with you, right? So those 4 lessons I've completed. The 4th lesson, chapter 4, that has half also you will study. Tomorrow that will also be over. For that will also be completed. That just needs one more extra class where it will be completed. How many lessons are now left? The first 3 lessons, and first 3 lessons will be completed in this batch. All right. Let us see if these 3 lessons till current electricity, if we are not able to do, because we'll have an idea. So before the mid of August or around the mid of August, daily I'll take your classes. Hafza, your exam is on 27th, no?
Yes, ma'am. And the first exam is physics.
First is physics. So on 27th only you're having physics. And Hafza,
Yes,
what
ma'am.
was the syllabus you told me?
Ma'am, till the 4th chapter we have electromagnetic induction.
EMI.
I
That's
mean,
not fourth.
yes. I mean 6th chapter. Yes,
Six
ma'am.
lessons, no?
Yes.
Okay. Fine. So let's see. For you also the same thing. Let us see the regarding the syllabus. It's on 27th August. No? So in the around mid of August, we'll have extra classes if it is needed. All right. Otherwise, I'll ask you to
Okay.
join the other batch also. But do not worry, it will be completed because the EMI chapter 5th, chapter 6th, both of these are very small lessons and AC is not coming, no?
No, ma'am.
AC is not coming. EMI and chapter 5, these are very small lessons. Mainly you have to focus on the first 4 lessons. So let us see how much we are able to complete. Otherwise for EMI, I'll hand you the notes also. For 5th lesson also, I'll hand you the notes that will help your studies. All right.
Okay, ma'am.